Right, we have to look at some advanced indices problems. Who can read the question?
4 to the power b plus 2 in method to the power b
Three halves. So in bracket 4b 4 to the power b plus 2 all to the power 3 halves. Give your answer in 2 to the power p, where p is in terms of b. You understand the question? Huh? This is an expression, math expression, which the number here is 4. But make the expression and replace 4 by what? 2. And p will be an expression of b. Do you understand the question now? All right. Now, if we have 4 squared, then I say express 4 squared as 2 to the power something. What will be the power of that 2? 2 to the power 4. So you understand this, but you don't understand this one because of b and p. Do I still have students who don't understand b and p are just numbers? You have an expression of b here. Here you have an expression of p. Change the 4 to what? 2. So you know how to do this one. You don't know how to do this one. Now, do you understand why 4 to the power 2 is 2 to the power 4? Fakon, do you understand? 4 to the power 2 means what? 4 times 4. Each of the 4 is what? 2 times 2. This 4 is 2 times 2. And the other 4 is also 2 times 2. So how many 2's are repeating now? So which is 2 to the power what? So Fakon, do you understand now? Huh? And are you writing it down? Look at this cocoyam. You think you have time again to write down? We are going very fast. I'll erase the board. So you have to understand exponents as a math operation, and only practice will make it perfect for you. So don't just stay there and then now only because you have variables b and p you are confused. Now, what do you understand here? If you bracket this 4 like this, you will have, you change the 4 in the middle as 2 to the power 2. Then you still have your bracket, but you still have that other 2 outside. Now that we have solved it to 4, so what's the relationship between these 2 and these 2? Is it multiplication relationship or addition relationship? You add these 2 and these 2, it's multiplication. It is not like they say 2 to the power 2 times 2 to the power 2. This one will be addition because this will be 2 2's and then another 2 2's. You add the number of 2's, you will add 2 plus 2 will be 4 2's that are multiplied. But this one is 2 to the power 2 all to the power again 2. Just like how you have 2 to the power, for example, if you have 2 to the power 2, but all to the power 3, all to the power 3, you will not say it's 2 plus 3, 5. Because this first 2 to the power 2 is what is repeating how many times? 3 times. You just have to go and first do the outer one. It's like when they give you multiplication, you have to first do the first multiplication before you do the next multiplication. If they give you multiplication of, this is 2 to the power 2. If they give you multiplication of 3 numbers, 3 times 3 times 3, or 2 times 4 times 6, if they give you 2 times 4 times 6, you cannot just do 2 times 4 times 6 all at once. You have to first choose these two or choose this other two first. 2 times 2, then you have 8 before you go and do times 6. So here is exponents. They give you 2 to the power 2 or to the power 2. So either you do the one inside first and you have 4, then it becomes 4 to the power 2. Or you do the one inside 2 to the power 2 times itself, 2 times 2 to the power 2 times 2 to the power 2. And then now, before you go and do all the individual things. So that is also when you have double exponents. This one is double multiplication. This one is double exponents. You choose to do the outer one, it will be like this. If you choose to do the inner one, it will be 2 times 2, inner first. You still have the outer one still there to the power 3. And then it will be now 4. The inner one now will be 4. Then when you do the outer now, 4 to the power 3 will be what? 4 times 4 times 4. You see. So there are two approaches. It's the same like you have 2 times 4. You can either do 4 times 4, which is 24. 4 times 6, which is 24. Before you come and do the 2 times 24, you still get to 48. Yes. So how do you open your bracket? So now let's come to this example, because these are the type of examples that if you can do this type of example, then you are a Morari student. So this is in bracket B plus 2. So you keep it like that so that you see it. Then you have to take B plus 2 plus 3 halves or times 3 halves. Times 3 halves, as simple as that. So 4, and then the whole expression now becomes 3 on 2 all multiplied by what? B plus 2. Because you have multiplied, becomes now this new bracket now. But 2, 4, so it means this is now what you have in your bracket here. 4 all to all this power. But this 4 is what? 2 to the power what? 2. That is how now you change the 4 now to have this base. Now you have your base. And then now, all again, now that it is 2, all again to the power what? 3 halves B plus 2. And now, who is seeing the final answer now? Who is seeing how easy the final answer is? 2 now goes and multiply again with all that. And this 2 multiplying with this, will you not cancel the 2 at the bottom? You will cancel the 2 at the bottom, and at the end, what will you have? So 2 to the power now, since those are 2 exponents, becomes 2 multiplied by 3 over 2, or B plus 2. If you say you learn indices at this age, already from 3, from 2, you should already know this type of question. So your final answer, 2 to what power now? 2 cancels here, since all this is multiplication relationship, so that 2 will cancel, and what you have is 3 times B, 3B, 3 times 2, 6. And now this is our 2 to the power P. So what is your P? Your P is the expression 3B plus 6. And you are done with this question. So you've taken something that has 4, you have turned it into something that has 2. So instead, if they say if B is 3, if B is 4, okay, for example, they say if B is 4 or if B is 2, or if b is 4, what is this expression? You can just come and put your 4 here. 3 times 4, 12, 12 plus 6. So the answer now will just give you 2 to the power 18. And if you have your calculator, you can calculate what 2 to the power 18 is. But if you don't have your calculator, you can split it as 2 to the power 10. 2 to the power 18 is 2 to the power 10 times 2 to the power what? 8. And we know 2 to the power 10 is 1024. And 2 to the power 8 is what? 256. So you don't know your powers of 2 right up to 10. Then who am I teaching here? Yam head. Write me all the powers of 2 right up to 10. 2 to the power 0, 1, 2, go like that. 1, 2, 4, 6, go right up. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. Those are all your 10 powers of 2. 2 to the power 0 is what? 2 to the power 1 is what? 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, 2 to the power 10, so that is that. And you can do the same for 3. You know all your powers of 3s. When you are in your own spare time and you are thinking about your math skills, what do? These are the type of things that serious students do. All right, so there goes that question. So it looks like a difficult question, but it's an interesting question just to help you apply your basic understanding of algebra. So you'll be doing your algebra, but on the air. All these things, b plus 2 times 3 halves, and then times again 2. So these are normal things that you can multiply on your own, but you are doing it with indices. So that is what indices is all about. Indices will really expose you to some good time mathematics. So let's see another question here. Another question here is this one. Okay. Now, this one says what? The root of 9. Now, root is what? When you have root, the 4x root of 9. What's the meaning of 4x root of 9? How do you change this? This is a 4x root. This does not mean to the power this 4x root. So how do we change root? That's something that you have to know, that roots are also very easy. If they say root x to the power n roots, when they put n here, is just x to the power what? X to the power 1 over what? N. X to the power 1 over n. So if it is a square root, because the square root will make from 2, so it will be x to the power half. If it is a cube root, it's x to the power what? 1/3. If it is the fourth root, it's x to the power what? 1 over 4. So this root, you would definitely put it as 9 to the power what? 1 over 4x. Easy as that. So it's just for you to follow the rules of things and transpose them. So that's what will be in that position. And now, if you have it like this, then if you say, okay, let's take the square root of both sides again. If you take the square root now of both sides, then it will like multiply by half. But if you square both sides, if we square both sides, let me see, if we square both sides, then we'll be having the square again. So this question is a very challenging question. The goal here will be something like this. If you can get what is inside here to also be the same as what is inside here, then we can now say, okay, what is in the exponent will be the same. So you have 1/3 and you have 9 here. So how can you go from 1/3 to get 9? So 1/3 to what power will give you 9? 1/3 to what power will give you 9? You will see some tricks here. 1/3 to what power will give you 9? Let's put 1/3 to the power -2. 1/3 to the power -2. What does it mean to have 1/3 to the power -2? It means that 1 will be to the power -2, and 3 will also be to the power what? -2. Now 1 to the power -2 is just 1, because 1 to any integer is just 1. Because 1 to the power -2 is what? Is equal to 1 over 1 to the power +2. Is that not how we do with negative? We put 1 over, and then we put it now in the ball at the bottom here. So here, and 1 to the power +2 is still 1, and 1 divided by 1 will still be 1. Then let's go to 3 to the power -2. 3 to the power -2 at the bottom can come up and be what? 3 to the power +2, or you can just do it at the bottom here as 1 over 3 to the power +2. And 3 to the power +2 is 9, so 1 over 9. So 1 divided by 1 over 9 is what? Is just 9. So did you know that you can change 1/3 to 9 just by doing this? To the power -2. So we go now inside this 9 and change this 9 to be what? 1/3 to the power -2, all to the power this. And then the -2 now we multiply to what? Multiply with this. So in place of 9, we replace it with what? 1/3 to the power -2 to the power -2. So, but now all this again is to the power what? 1 over 4x. So we don't forget our 1 over 4x. That's there. Ready. And then if we do that, we'll come here and erase this way. So I want to show us, these are some little tricks. And these tricks will only come by solving these type of difficult problems. You will not develop a robust mathematics skills if you don't deal with difficult problems. Now, these problems look difficult because you don't have some techniques on how to move from here to here. And you only have those techniques if you do a lot of practice. So now all this now becomes something that also has 1/3 on this other side, 1/3 all to the power -2 now times. So 2 will go here 1 time, 2 will go here what? 2 times. So that will just be -1 on 2x. So -1 on 2x. So here now the question becomes so easy now. If you have the same base raised to a power, and the same base raised to the power, it means what? Their two powers must be the same. Right? Hey, this is cocoa and equals cocoa. Then it means what? Their power should also be what? Equal before this equal sign is there. Tell me again, I don't understand. A 3 to the power A plus E is the same as 3 to the power A is the same as 3 to the power 2. What is A? Then here you are confused that this must be the same. You know this one very fast. What is A? 2. Before it can be equal. Of course, it's only when A is 2 before you say 3 to the power 2 is the same as 3 to the power 2. So here, 1/3 to this power equals 1/3 to this power. What is the relationship between the two powers? You are confused now because this one is a big expression. If these kind of things make you to be confused, then you are not ready for mathematics. So it means here what? Whatever. This is a number. This is a number. It can be a real number, fraction, decimal point. It's a number because x here is just a number. And it's just an expression that gives one number. So at the end, when you put x here, you square if x is 2, you put the 2 times 2 here. If x is 2 here, you put 2 square here. X is 2 here, put 2 cube here. And you solve it all. You may not have the number. So these two exponents must be the same. So you go now to that next step where you equate the two exponents. And then you see how we come closer to our answer. Very easy. So we say negative 1 over 2x is the same as x squared minus 2x all over 16 minus 2x cubed. Falcon, are you following? Okay. So now this one becomes now like an equation. That way you will solving for x. So in this case now, we can multiply both sides by 2x. Multiply both sides by 2x, or you can even multiply both sides by negative 2x, all depends. Because we want to remove this 2x from the bottom, you just multiply both sides by 2x. Multiply here by 2x, and then multiply this side also by 2x. So it's like a balance. When you have equal sign, it means you have a balance. Like this, you have things on the left. If you do something on the left, you do the same thing on the right, and this balance will still be equal. This is your balance, means your equal sign here. So if we do that, what we'll have will be 2x will cancel 2x one time. So we'll only be left with negative 1 here. And that will be equal to, on this other side, 2x will multiply the x squared will become what? 2x cubed. Well, there's 1x there that will multiply with this 2x. We got x cubed. And then 2x will multiply negative 2x will be negative 4x squared. So 2 will multiply 2, x will multiply x, will have x squared. And then here we'll have 16 minus 2x cubed. 16 minus what? Okay, very good. And then now we multiply both sides by 16 minus 2x cubed. And if we multiply 16 minus 2x cubed, this left side will be negative 1 all in bracket 16 minus 2x cubed, and our positive side will be, if we multiply all this by 16 minus 2x cubed, 16 minus 2x cubed once, 16 minus 2x cubed this way also once, right? And then we just have what is up there, which is what? 2x cubed minus 4x squared. Okay. Then now, once we multiply it now, negative 1 times 16 is negative 16. Negative 1 times negative 2x squared is positive. Negative times negative, positive 2x cubed. So this is the same as also what? 2x cubed minus what? 4 minus what? You are not speaking. When you speak, then it goes to your brain, 4x squared. All right. Now, if both sides we have 2x cubed here, 2x cubed here, we can just cancel them from both. Yeah. If you have a scale and you have 2 and 8 here, and then this way you also have 2 and 8, 2 and 8 here. You can just remove the 8 here and also remove the 8 here. It will still be balanced. So you remove these two things, and they are all positive, so you remove them. And your final thing will be what? Negative 16 equals negative 4x squared equals 4x squared. All right. So negative 16 equals negative 4x squared. Okay, let's keep solving and going up now. Okay, now if I remove, I want to put everything to the right, everything to the left, sorry. This is negative 4x squared. Then I add 4x squared to both sides. This side will be what? I add plus 4x squared to both sides. This side will be what? And then this side will be what? So you first write the positive 4x squared that you add. 4x squared minus what? 16. That's what will be here. 4x squared minus 16. So what do you think this x will be so that this thing will be 0 too? If x is 2, 2 squared is what?
4.
Times this 4.
16.
16 minus 16. So x as 2 is fine, is one of the answer. Then if x is negative 2, negative 2 squared, positive 4, times 4 again. 16 minus 16. So you see, you found the answers. So the two answers here, or we can say, let's do quadratic equation. And if you can do quadratic equation here, you understand that this b is what? 0, and AC is, first you can just divide both sides by 4 first. Divide everything by 4. This side by 4. 0 divided by 4 will be 0, still 0. 4x divided by 4 will be what? X squared. 16 divided by 4 will be what? 4. And all will still be equals to 0. So now you can just see how x is plus or minus 2. And then you can just do x equals to 4. Now you send 4 that way, it will become what? X squared equals to what? 4. And then now you do what? You take the square root of both sides. Square root of both sides. So if you square this, you have what? X. But if you square root of 4 is equals to what? You know that square root of 4 is what? Plus or 2. Because if you square negative 2, you still have 4. If you square positive 2, you still have 4. So the square root of anything will give you the plus and the minus. You should always remember that. Because if you multiply negative, 2 negatives, you will get positive. You multiply 2 positive, you still have positive. So the square root now gives you plus and the minus. So, and that's your final x. You have negative, or you multiply a positive times negative, you have negative. when you multiply two signs that are the same, you have positive. Multiply two signs that are different, you have negative. So this is a difficult question. Was this a difficult question? Where did you learn? You learned something that 1/3, once 3 has a relationship with 4, we can always get it. If you have half here and it's 8 here, you can also do it. If you have half here and it's 4 here, you can also do it. If you can do something with this 3 to get this 9, then you can always do 1/3 to get to this, or 1/9 to come to 3. You can always do it. Yes. Just by thinking, just think out of the box. Because whatever is down here, to bring it up, we just put negative. Yes. All right. And then once you have 1 here, it doesn't matter, because 1 to any power, positive or negative, will still be 1. Or it doesn't matter to any power, even if it's a fraction. Cube root of 1 is still what? 1. Fourth root of 1 is still what? 1. So again, those are the things that we have to keep into consideration. So this question look difficult, but easily solved. Now these are the kind of questions that they give for the GCE, London GCSE. The London GCE, the General Certificate of Secondary Examination. Okay, so again, we can do this type of problems. You can go to London and take the exams now. Well, this one is kind of easy, but it might look here as if though it's difficult. Do we solve it?
Yes.
Okay. So it says, take this, divide by this, and then multiply by this. All right. So what we are seeing already, we are seeing the 12 multiplied by the 12 is the same exponent, but yeah, not the same. All right. So how do we go about it? Let's just look at this division part, and we will see that it will be very easy if we just say, okay, 12, and this is to the power 1/3. Okay, what if we also need to take this 81 and we also make it to the power 1/3? Because if we do that now, we can join it now together. 81 to the power 1/3. So how do we get 1/3 from this 1/6? Is what? Half times what? Half times what? And that will give you what? So you come and you put the half inside, and you put the 1/3 now outside. And then you have what? 1/3 here. And then, of course, the 12 also has its 1/3. You see how easily we have changed this? You see? Oh, that was 81. So you see? And 81 to the power half is what? Jesus! 81 to the power half means what? Square root of 81. This person is divided. This person is still thinking. Power, not divided by 2. Jesus. When do you want to get indices to be in your head? 9. And then now, once you have that 9, you see that all this just becomes 12/9, all to the power what? 1/3. Because if you have 1/3 on something, 1/3 on something, we can first do the division before the power, or you do the powers before the division. This is normal things from what people have learned. Now, 12/9, easily solved. 12/9 is what? 3 here, how many times? 4 times 3, how many times? 3 times. So you simplify that. That becomes 4/3 to the power a third. So you simplify all that part to this one, power a third. And then now this is what they say, take this result now and multiply by something also that has a third. Something that also has a third. Now if you have, okay, if you have 2 squared and 3 squared, like this, can you first do 2 times 3 squared? Can you first do the times before you come and do the square? Is that possible? Eh? Just like what we do with division. So this is a fun thing about it. We can first multiply it, and then here will also just mean 2 times 3. Whatever is inside here, repeat it 2 times. It will be now 2 times 3. Then repeat another 2 times 3 again. Another 2 times 3 again. But when it's here, it will be 2 times 2. And then what? 3 times 3. So this just means at the end, it will just be rearrangement problems. This and this are the same. It will just be rearrangement problems. So always understand the meaning of exponents so that you can just do the meaning first, not using rules. But now after you know that they are the same, now we can just use the rules to help us. Shortcut. So now this question now becomes 4/3 times what? Times 162. All to the power a third. You see? Now, this thing that was looking like they were different numbers. Okay, 3 here we do short division. Now who knows how to do their short division? 3 here, 1 time. 3 into 16.
5 times remainder 1.
5 times remainder 1. And the 1 with these 2 is 12. And 3 into 12? 4 times. So that is 4 times 54. Then 4 times 54 now, what's the answer? 4 times 54 is what?
216.
216. So now you have 216 to the power a third. It just means 216. What root? To the power a third, is it not cube root? You keep forgetting. Cube root. So what number do we multiply 3 times to give us 216? So you can just start with 1. 1 times 1 times 1 is what? 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6, 36. 36 times 6, 192. 36 times 6, 192. Huh? How did you get 192? 260, 192. Jesus is not. 36 times 6. It's not 180 plus 36. 36. Oh, 36 times 6. Is it not 30 times 6 and then 6 times 6? 30 times 6 is it not 180? 6 times 6 is it not 36? 180 plus 36 is what, Fakon? 180 plus 36, Fakon. So cube root of 216 is what? 6. So all these questions, all this yam head here, few was just what? 6. And then you look at it, you will like, yeah, it's difficult, it's hard, but it's just little tricks. And those little tricks, they help now to bring all the rules that you have learned with indices. Indices is something that there's so many tricks. This one you can do like this you can do like this. But they all have their original place where they start. And with understanding of those little tricks, you see how you can solve some interesting problems and arrive at interesting solutions. So that one is gone. Now, what other problems again? Me, I've never seen these problems before in my life. I'm just seeing them now. But then, when you think now, you think with all the rules in your head very fast. I have 1/6. I can see 1/3 there. So I just take the half now inside and put the 1/3 out and multiply everything in the middle, all to the 1/3. But if you do it very fast, you'll be doing what? 12 divided by 9 and all that. So you can just do all the things first there, and then it just become very easy. Because 81 to the power half, if you don't see a square root of 81, then you have a problem again. Then you cannot go very fast. So at the end, you just do 12, you do divided by 9, and then you do times 162, then all this to the power 1/3. So you can just simplify. That's your first step. You go here, people will be like, wow, that's a genius. You just get here. And then all these things in the middle will just give you 216. 1/3 means cube root. Fab. Second step, answer comes out like great. Okay, so again, what did we do here? We just went to Google and I said difficult problems of indices, difficult indices questions. That's what I just searched on Google. So that you challenge yourself with those difficult questions. And this is how you use the internet to study. Not to just go and find answer, do this for me. No. Take the internet to search for difficult questions and you compete with the best of the best in other parts of the world. Now look at this one now. Look at this other problem. There's this other problem. Even though Aquila has not done quadratic equation, sometimes from this you can get some questions that look like quadratic equation, but you can still solve them even if it's not quadratic equation. Now look like this. Look at this one. It says, now they say 4x minus 2x plus 2 minus 5 equals to 0. Then how can you change this to something easy before you go and solve it? And they say you can change it to y squared minus 4y minus 5 equals to 0. And this one is a quadratic equation. And that will be easy now for somebody like Miriam now to solve. But how do you change that? In fact, in the exam, this is how they give you questions in the GCE like this. So that you will think now to solve it like this. Now 4 square, how do we do the 4 square here? We say 4 is the same as 2 to the power 2. And then that 2 now multiplied by this x will be what? 2x. Then this way will be 2 to the power, since it's plus here, it means 2 to the power 2x times what? Times we put a big dot in the middle, times 2 to the power 2. You know how they got to 2 to the x? No. Remove this x. Sorry. Remove this x here. Do you know how they got to 2 to the power x plus 2? When do you add the indices? When you multiply with the same base. So this was 2 to the power x times 2 to the power 2. So you bring them back to their original form. So it's not only going from here to here. Sometimes we can go back the reverse. So keep that in mind. And when you go back now in the reverse, that is when now you understand that it will be very easy now for us now to go to the final stage. Now, this one now you have to put now bracket like this. Either you put a bracket like this. If you put bracket like this, you come back to 4x. Now you have to change. Instead of the x before the 2, we put what? The 2 before the x. Now, how do you put the 2 before the x? So these are also some you know that 2 times x also means what? X times 2. So 2 to the x here, and then in bracket what? 2. The 2 now goes outside. And then here now, 2 to the x times 2 to the 2 becomes what? 2 to the 2 first times what? 2 to the x. So you see, only arrangement also is so important in science. Arrangement. Arranging things. But with practice makes perfect. You just start knowing what your next step will look like. You see that the way I'm solving now, for you that have never done this, it's very slow in your eye, yes or no? It's very slow the way it's happening, right? But if we do this example, I will come and do another example, I will come and do another example, I will come and do another example, like me, that have solved more than 50 of this type of problems, you see that I just know what the next step will look like. And that is when now you can go and take part in international competition. Have you already taken part in an international? You mean me? Of course. I took part in IBM. IBM is a company, American company. They gave a mathematics exam in Shanghai, 40,000 students, and I was in the top 300. So here, 2 to the power x, now I can say, okay, let 2 to the power x be what? Y. So all this now becomes what? A new variable, y, and that will be just y squared. And then this is 2 to the power 2 is what? 4 times what? 2 to the power x, which is what? Y. So it just be times 4y. And then minus what? 5. And then equal to what? 0. Then how do we find this y? The fastest way to find y, you can start by guessing. Okay, let's guess that y is 1. If we guess that y is 1, it will be what? 1 square, which is what? 1 is 2. Look at some stupid mistakes that sometimes you make. 1 square means 1 times 1, which is 1. Then here, negative 4 times positive 1 is what? Still negative 4. And then minus what? 5. Does it give 0? 1 minus 4 is negative 3. Negative 3 minus 5, negative 8. So it doesn't give 0. So if y is equal to 1, that is a very wrong choice. So if it is not 1, you try negative 1. So you always try plus or minus 1. You see which one goes. Let's try negative 1. Before we go to 2, before we go to 3, we also try plus or minus 2. Because now you are dealing with integer, don't only think about positive number. So let's try y is negative 1. If y is negative 1, negative 1 times negative 1 is what? Positive 1. Then negative 4 times negative 1 is what? Positive 4. Then minus 5. Let's see if this will give us 0. 1 plus 4, 5. 5 minus 5, 0. So y should be negative 1. Y should be negative 1. Then we go and say, okay, y equals negative 1. But y is the same as what? 2 to the power x. So all this equals what? Negative 1. So 2 to what power will give us negative 1? 2 to what power will give us negative 1? How do we solve this type of question? How do we solve this type of problem? 2 to what power will give us negative 1? The answer is impossible. Is the answer impossible or possible? Because 2 to a negative number is still a positive number. 2 to a positive number is a positive number. 2 to a negative number is also a positive. 2 to negative a is the same as what? 1 over 2 to a. If a is positive. So it means 2 to positive number is positive. 2 to negative number is also positive. So 2 to a power will never give. So though y is -1 here, but in that case, we'll not get the solution. So we have to go and find another y. Because y is raised to the power 2 here, there will be 2 y's that will satisfy this equation. So let's try another one. Let's guess 2. If y is 2, positive ones don't usually work. Negative one might work. So if y is -2, then we'll have 8 here in the middle, right? And then this will be what? 2 square. But 2 square plus 8 will be what? Bigger. So that one will not also work. Is it something less than 5? Because this one will come out. So let's try positive. So positive 2, 8. Positive 2 will be -8, so it will be -13, so it's not good. Let's try positive 3. Positive 3, this will be 9, right? Then this will be what? -12, -1 is not good. Let's try 16. 4, right? 4, there will be 16. Then this will also be -16. We'll still have -5. Let's try 25. Let's try 5. 5 square.
5.
And then here we'll put positive 5. 20. And this one, 25, right? So y equals to positive 5 is the other y. So there are 2 y's. Y as -1 and y as positive 5. The y at -1 will not work. So it means that y, which is 2 to the power x, is equal to what? 5. But 2 to what power will give us 5? It will not be any whole number, because any powers of 2 are just what? 1, 2, 4, 8. There's no 5 there. So how to get this x? We have to go now to something that we have not solved. It's called log. We take log at both sides. Log here, and we also take log of 5. In your calculator, did you see log in the calculator? So when you take log of both sides, this x now will go to the front. X will go to the front and become x log 2. X log 2. X log 2 equals log 5 or equals 5. Equals log 5. Then you see now, x now is what? Very easy now. X now is what? Log 5 over log 2. You divide both sides by log 2. X times log 2 is not the same as log 2 times x. Then you divide both sides by what? Log 2. So the answer is what? X is equals what? Log 5 over log 2. That's the answer of x. So this question, they will be asking you this question at GCE. You would have already studied your log, and that will be your final answer. So log of anything raised to that power can go to the front. And when you study log, you also understand the rules. Log also has similar rules to indices, but they are very nice, because log is actually the opposite of power. That's why the power can go to the front. Yes, log is the opposite of power. So, and here we are using but not log 10. You can use any other logs. So here again, we've solved this problem and we've had our answer. And this quadratic equation, we solve it using guesswork. You can solve it. Right now, we'll solve it now using what? Using factorization. You know factorization? B is -4. What two numbers you add to give -4? -5 and +1. And then when you multiply it, you also get -5, which is AC. It's not a +1 and -5. So you just come here with what? X plus 1 in bracket x minus 5. So it'll be y plus 1 bracket y minus 5. Then if each side is equal to 0, y plus 1 equals to 0, will be y equals to -1. Y minus 5 equals to 0, will be y equals to 5. So you would have solved this thing because you have studied quadratic equation. Because you just do factorization. That is b there, -4. A here is 1, C is -5. So what two things can add to give B, and what two things can multiply to give C, AC. And that's it. All right, so again, easy. Again, we are taking difficult questions from the London GCE, and in the Cameroon GCE, it might also be this type of question. Now look at this one here. Look at this. Hint for the first to this, to this, to this. Just change your 4 here to what? 2 to the power 2. And then when the 2 multiplies the B, you have what? 2B. And the 2 multiplied the other 2, you have what? 4. All this one to this. And then you have this. Oh, that was that question that we solved. Here they are showing us the solution. This they call it answer. So we had already solved this. So these are some of the clues. Yeah, this was this question. Okay. So again, when you go online, we do more of this. That one was already, we were already inside that part. Yeah, we are still here. So some of these things also have solutions. So again, so look at this crazy one. They say all this one will go and give 64 on, or they say all this is equal to 64 on 125. So solve for x. Or this is just a question that they ask us to solve for x. 125 here, 64 here. So, but these are easy now. Square root of this square root can go on 16, and then the square root can go on 25. Square root of 16 is 4 now. Square root of 25 is 5.
Yeah. 5.
You expand that, and then you can easily get, this is easy now. You can easily get to that. And then, so you have but 4 over 5 here. And then this is the power. Then this 3 will come and multiply here too. Then see if you can also get 4 on 5 here, right? So you already know you are also looking for 4 on 5 here. At the end here, you have 4 on 5 raised to any power. Here also you need to get 4 on 5 raised on what power? This is 4 to the power what? 64 is 4 to the power what? That is 256. 64 is what? Do it now. 4 times 4 times 4. First do 4 times 4, you have what? 16. 4 to the power 3. How do you do something without applying the indices before you guess? That's guesswork. You did not do any calculation in your brain to get it. That's not how a moral student thinks. You think with a method and think fast using that method before you are sure of your answer. You just guess 4 to the power 4. Or you think 4 to the power 4. How do you even get there? 4 to the power 4. You do 2 of the 4 gives 16. 2 of the other 4 gives 16. 16 times 16. Is it 24? 64. 16 times 16 will be something very big. 16 16ths. So that alone should be able to help you judge. You do, if I do 2 4s, it's 16. So it's not 64. If I do 3 4s, I first multiply 2 4s, I have 16. 16 times 4 means 16 and 16 and 16 and 16. 2 16, 32. 2 16, 32. 32 and 32, 64. So fast in your head, and you know that it is 4 to the power 3. Then 25 is what? 5 to the what power?
5 to the power 3.
5 to the power 3. 5 and 5, 25 times the other 5 gives that. So here you already break this to 4 over 5 all to the power 3, because this 4 will be to the power 3. This 5 will also be to the power 3. So you can group all this to the power what? 3. And then here also, this is also 4 to the power 4 over what? 5. By the time you use your square root, this is also 4 to the 5. So if you have the same thing to this power, the same thing also to this power, it means their indices must be the same. So these indices now, this 3 is out. Multiply 3 by this, you have what? 12x. Multiply 3 by that, you have 12x. Multiply 3 into the 9, you have what? Minus 27. Then must be the same as what? 3. The same as 3. Then 12x. 27 crosses the other side, become positive 27. Or you say you add 27
Equals to
on
30.
both sides. Here will disappear. Here you add 27 will be what?
Yeah.
30.
Equals to 30.
So your x will just be what? 30 divided by what?
12.
12. So you say 6 here how many times? 5 times. And 6 into 12 how many times? 2 times. 5 divided by 2, 2.5. And you've solved your x. Easy as that. X is 30 over 12, which is what? Improper fraction. You reduce the improper, simplify the improper fraction, you have 2. If I come, use their HCF. The HCF of 12 and 30 is 6. The highest common factor of 12 and 30 is 6. So just divide one time by the highest common factor and you simplify. Don't go and say 2 is to 30, 15. 2 is to 12, 6. Then you go again. 3 into 15, 5. 3 into 6, 2. Don't do step by step. That is why you study highest common factor. You study highest common factor that if you want to divide two numbers to simplify them, just find their highest common factor and divide each by the highest common factor, and you just do it once. You not do it twice. What do I mean? We want to simplify 30 divided by 12. Why did you people learn ACF? Because some of you will just learn ACF and you say, okay, since I learned ACF and we did exam, I will never see it again. I will never see ACF. Now, if you want to do 2 year 15, if you start with 2, then yam head, you will never end. You go here, 2 year what? 6. And then you go here, 3 year what? 5. And you go here, 3 year what? 2. So why all this rubbish just to simplify? If you know your highest common factor, you will not do all this. You say, okay, I want to simplify 30 over 12. What is the highest common factor? The highest common factor is 6. So I just do 30 here divided by what? 6. And I do at the bottom also, I do what? 12 here divided by 6. And just one step, I will simplify it. 30 divided by 6, 5. And 12 divided by 6, 2. Because you use the highest common factor, they will have no factor anymore because you have removed the highest factor that is common amongst the two, and nothing will be left. So you just simplify to the simplest form. And those are the kind of skills that you should have. You should connect all your math skills. You don't study highest common factor to never see it again. You don't study LCM to never see it again. All these things, they have use. And that is, and a student who does this and a student who do first, you start with 2, you start with the smallest one. Because that is what people are used to doing, starting with the smallest one. A student who just does one step and is in the answer will take part in international competition because there is about time. You have 1 second to give the answer. They just put on the board, simplify 30 over 12. And you are, 2 year, 2 year, 3 year. All the Chinese students, Indian students have already gotten the answer. They have moved to the next one. Or they give you 10 questions, you have 10 seconds to write all the answers. Or they give you 2 seconds for writing your answers and 1 second for you to reason. And then after 10 seconds, everybody is finished, you are in the second problem. You've used 20 seconds to think about just one thing because you are there slow. You even don't know how to write fast. So all the skills for you to reason fast, write fast, do fast, is all the skills that you people have to cultivate. So again, my students are students who need to really step up to the plate. So look at another example here. 4 to the what? Where is that example? I clicked here. Where did it go? You have so many of these things, and they are not like they are any serious question. Okay, look like this one. At least they have shown you the steps. 8 squared times 8 to the power 3 divided by 8 to the power 4 is 2 to the power n. Now this one is easy. These 2 here and 3, we have to add them from the rules. You add 2 and 3 because you are multiplying things of the same base. You add 2 and 3, meaning that there will be total 5 8s that are multiplying each other. So that's 8 to the power 5. And then now you have, and that's what they have done here. And then now, if you divide, it means at the bottom, there are 4 8s. multiplying each other at the bottom, 5 8s multiplying each other at the top. If we cancel the 4 8s, 8 here one time, 8 here one time, 8 here one time, 8 here one time, all the 4 8s at the bottom will cancel 4 of the 5 8s at the top, and we'll be left with only 1 8. And 8 is just 2 to the power 3. So your n here is what?
3.
N is 3. So these are very easy ones. These are very easy ones to start. You start from those easy ones, and then you begin to graduate now to a lot more exam-style questions. Yes. And then exam-style question, they can ask you to simplify something. Look like this one. When I click on a question, it doesn't even open the question. I go and open jargon. Look up where? Where's up? Okay, so look at this one. They say what? Work out the answer to the following. Show all your workings. Good. So they say this one will lead to probably one answer. So first you have to observe it. You have to observe. There's something about observation. If you observe here, what are you seeing? You are seeing that these indices and this index and this index and this index are the same. This index and this index are the same. So you can just group them and you make 2 divisions and multiply them. Okay, that's another way to do it. But is there another way to just bring all of them together? Well, this one that is ending with 3 and this one ending with 3, this one 3 at the bottom, 3 at the bottom, we can bring all these 3 together. And then this one that is ending with 2 here, we can also bring it together. In fact, we can bring all of them together by introducing a new 3. See, you see, all these things they need 3, they have 3 at the bottom. Now, we are trying to bring 3 in here. Now, look at how you can introduce a new 3. Can you bring 3? Can you put 3 under here? Look at something. Look at a very good technique. Now, I'm doing all this because all these techniques, I developed them over time. The index here is what? 3 over what? 2. What if you come and multiply this? How do you bring 3 at the bottom? You can put 3 at the bottom. You have to also do what? Remove the 3 at the top. 3 over 3 is what? 1. But now, because you want to keep this 3 at the bottom, what do? You take this 3 and multiply by this 3 at the top, and now you have, what do you have at the top now? You have 9 to the power what? 9 over 2. 9 over 2 like this, in bracket what? 1/3. Do you see how you have brought 3 now? Do you see how you have brought 3? Because you have multiplied by 1, but you have expressed the 1 as what? 2 over 2, 3 over 3, 4 over 4, 5 over 5, 6 over 6. But then you take one of the 3 up, you introduce it somewhere else, and now this 3 now is standing now as what? This skill now is only for this is the end skill, the top of the top, only the 1 out of million of students in this world. That's why geniuses in this world, there are not many. So this is a place where there is no 3, but you bring a 3. There's no 5 here. Can you bring a 5? 5 over 5. But when you are still making your head like that, you have not understood what we've done here. Can you bring 11? 11 over 11. And this one, 3 times 11, 33 over 2 and 1 over 11 are here. What's the trick? Multiply by 1. 1 is any number divided by itself. So you bring in something here, and this is a skill only for students who say, oh, yeah, it's normal. Yeah, it's okay. Until it becomes normal for you, it will only remain difficult. Because your own mathematics it should be like, they should give you a number. It should be there before you accept it. So here is not for the faint of hearts. So if we bring the 1/3 like this, we'll see that everything now will be raised to 1/3. And then this 3 to the 2, and this will be what? 3 square, and then 1/3. Will be 3 square, and then 1/3. So if you arrange everything to 1/3, then we'll have one giant thing, and all will be to the power what? 1/3, which is cube root. And if you also know that 1/3 means cube root, then that is good. If you don't know that, then I'm sorry for you. So what will be left in the middle here, since this one is to the power 1/3, so it will be 9 to the power 9/2, 9 to the power 9/2 there, and we'll multiply that with what? 2 to the 6, multiply that to 2 to the 6, and then we'll divide that all by, it will be 3 squared, and then multiply by 3. Okay. So now they say we should work out the answer to the following. So let's come here and try to see. Let's come here and try to see. Now, 3 to the power 9, 9 to the power 9/2. These 2 at the bottom means square root. Yes or no?
Yes, sir.
So again, 9 to the power 9/2 can be expressed as 9 to the power half all to the power 9. And 9 to the power half is 3. It just means square root of 9. So that is 3 to the power 9. So you see how this part will collapse again and becomes 3 to the power 9. Right, boy? Right, boy? Do you get it?
Yes, I get it.
So this becomes 3 to the power what? 9. And then
9.
we have three threes down here, right? We have 3 times 3
Yes.
times another 3. So the bottom again collapse to what? 3 to the power 3. So you see how all of a sudden everything now is just on the number 3 and 2. So that's all. And then now here becomes 3 to 9 minus what? 3. So 3 of these 3's will cancel 3 of the 9 3's up there. And we'll have 3 to the power what? 6 times what? 2 to the power what? 6, all in bracket to the power 3rd. We've seen how all these things have become awfully simple. Then instead of 3 to the power 6 times 2 to the power 6, we'll first do 3 times 2, all to the power what? 6, and then all to the power what? Don't forget your 1/3. 1/3. And then this 6 and this 1/3 can also multiply to give us, finally, we have what? 3 times 2 is what? 6. And then 6 times 1/3 is what? Jesus. 3 here one time, 3 into 6. Jesus. You still want to be thinking seriously. Where are we headed? 6/3 is what? 2. Jesus. And it becomes 6 squared, and 6 squared is what? 36. So all this mumbo jumbo here gives 36. It says, show your work. Simplify, show your work. So if you learn indices and you just learn it at a small level, 2 to the power 8 is 2 times 2 times 2, 8. If that is where you want to end, then you are going nowhere. Indices means you have expressions like this, interesting expressions like this. And then you see how you just work with all the rules around indices. Bam, 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 and knowing that all your fractions are all roots. 1 to the power 2, if you see 2 as a denominator somewhere as an index, that is a square root. If you see 3 somewhere, that's a cube root. 4 somewhere, that's the 4th root. And the 4th root means a number when you multiply by itself 4 times will lead into something that is inside the root. For example, if I say, what is the 4th root? And that's where I have to put my 4. What is the 4th root of 16? The 4th root of 16 is 2. Why? Because 2 to the power 4 will give me 16. So that's the meaning of the 4th root. So all these terms are with indices. And then when you have something like this, it means instead of saying that 4th root of 16, we can also say this is the same as 16 to the power 1/4. So these are things that you have to understand. So 16 to the power 1 over 4, we can write it like this, or we can write it like this, or you can go from year to year. And in most of the time, in some questions where they have expressions like the fourth root, you just change it to what? 16 to the power 1 over 4. And you see how you go and cancel something. If they say, okay, the fourth root, see, they give you a question and they say, these, and they put this one, 4 here, and they put all these, and they say in bracket 8. All this in bracket 8. What is this? Oh my God. This is just 16 square, 256. But look at this expression. It looks like too confusing for you. But in the bracket here is 16 to the power 1 quarter. 16 to the power a quarter. Then all now to the power 8. And then now, since it's power to the power, you just have to multiply your indices. A quarter of 8 is 2. So these are the small expression that will go. And then again, when you see X, A, B, P, T, algebra, don't be confused. Even easy again. A student that will look at algebra and still be confused with X, Y, B, P, A, B, C, all these things, again, you are going nowhere. You are going nowhere because all of math, complex mathematics, is abstracting things and be working with variables. Just the same way you can work with whole numbers and work with fractions, negative, positive whole numbers, negative, positive decimal numbers, all these things. I can say 2 to the power 0.5. It should not surprise you. I have to change my 0.5 into fraction. I can say 2 to the power 0.25. I have to change my 0.25 into what? 1 quarter. So 2 to the power 0.25 is what? The fourth root of 2. So your power can also be negative number, positive number, can be fraction, can be decimals. All that will complete your understanding of indices. So again, today I said, let's look at indices. Let's look at some problems that might be a little bit like tricky, but not tricky at all. And you learn indices at school, just go and take some examples like this. They say evaluate. Or this type of question, when they say evaluate at x equals to what? They have to give you the x. Or evaluate it, or they will say simplify it. When they say evaluate like this, evaluate means find the value. So some people don't know how to set question. When I look at question, except somewhere here they say evaluate at x equals something. Evaluate means find the value at the end. So you also have to know how to interpret mathematics question. Evaluate means find the value. So they have to give you what x is. Like good, this one they can say evaluate, because this one will just mean the square root of 4. And this one means what? The cube root of 8 or square. Cube root of 8 is 2. 2 square is 8 to the power 2/3. Aquila is seriously looking at it. 8 to the power 2/3. What's the answer? 8 to the power 2/3. What's the answer of 8 to the power 2/3? It becomes 8 to the half or to the third. And
which is 4.
8 to the third, rather. 8 to the third or to the half, or to the square, which is 4. 8 to the third is 2. 2 square is 4. So those are the kind of things that they'll ask you. And then if somebody comes and say x to the power 1 on y, what is this? X to the power 1 on y is the what? Wife with th, the wife root of x. That's the meaning. So don't get confused, because y there is a number. Y is a number. So again, these are things that as a math student, only when you start challenging yourself beyond the type of questions that they ask in Cameroon before you you really know. Like this example. So this, first you put your 1/3 inside, and then you put your 2 outside. The 1/3, you get it 4, and then 4 square, you get 16. So those are all examples. These are all good, 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 good. Oh, yeah, this is what they mean by evaluate. You see, evaluate, because at the end you get a value. So everything should be numbers already. So they have already put your x and the y there, because they will say 10 to the power x over y. X is 1, y is 2. Yes. So all this will evaluate. Then look at 200 to the power half. I love this type of question. 200 to the power half means the square root of 200. But how do you solve it? How do you solve the square root of 200? 200 to the power half is the square root of 200. Will you say, I don't know the square root of 200? No. 200 to the power half, this is what you will do. You will bracket like this, and then now you take the 200 and you go to work. 200 is what? 2 times 100. And then now this is when now you bring that half now to the power half. And then now when you have two things like this, what does it say we can do? We can do 2 to the power half multiplied by 100 to the power half. Now the 100 to the power half now is the square root of 100, which is 10. And then this 1 and 2 to the power half is just root 2. So your answer is what? 10 root 2. And if you already know root 2 is 1.414, root 2 is what? Approximately 1.414. At least, see, there are certain roots that you just multiply, you just memorize them to at least 3 decimal places. It's just the same way you say pi is 3.141. You or one if you round up, because it's 3.141628, something like that. So if you do it to 3 decimal places, it will be 3.142. Okay, so if you do 10 now multiplied by this, will be what? 14.14. You see? 14.14. So you see now 14.14 is the square root of 200. Now take 200 in your calculator and do the square root of 200 and see if you'll be closer to that. You know, this is an approximation. It will not be exactly that, but it will be approximately to that. So if I take my calculator and I turn it the other way, turn my calculator of my phone the other way, I have 200 and I do square root is, look at the answer, 14.142. But if you put it to 2 decimal places, it will be what? 14.1. So you want to take that 2 there and round it to 1. 2 is not. You know how to round up. People have learned how to round up decimal places. When you have a decimal place like 14.142 and you want to round it to 2 decimal place, you look at the 3rd decimal place. If it is not up to 5, then you throw it away. It's like you have from here to the ceiling is 1. Then something is just 2 steps. Is it closer to the ceiling or closer to the floor? So throw it away. If it is 4, is it closer to the ceiling or closer to the floor? Throw it away. If it is 6, closer to the ceiling or closer to the floor? Then you round it up to 1. And then now you add it here now to become 5. So that is called floor and ceiling. That's how you think if you want to round up or round down. Throw away or you make it. So these are the type of questions that you can go and solve. So this becomes your homework for today. Copy these things and evaluate them. Okay. Why are you not saying? view, zoom in, view, zoom in again, view, zoom in. Can you see now? Right, boy. If you go to Moreri Enterprises YouTube, did you see the video that I did there on science?
Yeah, I saw one of the videos, but I don't know which one I'm talking about because I've been trying to do some of the work lately, so I've been checking out more science videos so I could learn more.
There's a video I've done on Moreri Enterprises YouTube page. It's called Innovative Science. The name is there. You cannot miss it. And it has the picture of the encyclopedia there. So I uploaded that video probably yesterday, or was it today morning or yesterday? I've uploaded another video on English. So that one is also there. So watch those videos.
Okay, no problem.
Huh? I don't know why you're asking that question. How many questions do you see there? Mhm. Your parents gave you money to school, and then do you ever ask them that I should eat all of this 200 or all of this 100? Do you ever ask your parents that? Hey, young man. All right, boy, you have taken a screenshot because I want to go offline now.
Okay, no problem.
All right, class is over.
Okay, thank you for the classes.
All right.
Bye.
Right. So here we are done.